Hi, Jesse. Who else is here? Say hi in
here.
the chat. Okay, good. Anybody else? I see
Hello.
Naomi is here. Okay, good. All right, good. I see several people. Thanks, Mercedes. Thanks, Viviana. Thanks, Lucina. Okay, we're going to talk a little bit about the division algorithm. That's just a name that we give to the process of dividing, usually with long division. So if we have two things and we're dividing them, if we have F divided by D, we get an answer that's called Q and a remainder that's called R divided by D. We call Q the quotient, R the remainder, F is the dividend, and D is the divisor. So let's look at two kinds of long division, one with numbers and one with polynomials. If we're dividing, or let's see, put some zeros in here. If we're dividing 1,460,912,312 by 273, then we would call the number that's being divided is the dividend. The number doing the dividing is the divisor. The whole number part of the answer is the quotient, and the remainder is the number that is left. We can use the division algorithm to rewrite this answer. So we could say, let's see, I'm going to put the original number, 1,460,912,312 equals, I'm now going to write down the divisor, 273 times, let's see, times, oh, the quotient. The quotient is 5,351,327 plus the remainder, plus 41. I could also write this answer using this first version. So I could write F divided by D equals Q plus R over D. So let's see. F is the dividend. So 1,460, 912, 312 divided by, the divisor is 273 equals the quotient. The quotient is 5,351,327 plus the remainder divided by the dividend, 41 divided by 273. So both of these answers are using the division algorithm. We take the original number, the number doing the dividing, the divisor, the quotient, divisor, quotient, remainder, and we'll call the dividend div. So divisor, dividend, quotient, remainder. Well, we can do the same thing with polynomials. So in this example, the dividend is the number being divided. That's 2x to the fourth plus 5x cubed plus 7x squared plus 16x plus 15. The number doing the dividing is 2x plus 3. That's the divisor. The quotient is the whole number part of the answer. And the remainder is whatever is left at the very end. So we could use the division algorithm to write this answer. Let's see, the two ways are F over D equals Q plus R over D. So let's do that way. We have 2x to the fourth plus 5x cubed plus 7x squared plus 16x plus 5, all divided by 2x plus 3, the divisor, equals the quotient, that's that whole long thing, x cubed plus x squared plus 2x plus 5 plus the remainder divided by the divisor. The remainder was 0. The divisor was 2x plus 3. So we don't really necessarily have to write down 0. The other way we can write the answer is F equals D times Q plus R. So let's do that. 2x to the fourth plus 5x cubed plus 7x squared plus 16x plus 5 equals 2x plus 3 times the quotient x cubed plus x squared plus 2x plus 5 plus the remainder, so plus 0. Now, we're not going to do that in our class. We need to know what these terms mean, and we'll have an opportunity to find divisors, quotients, and remainders, but we're not going to do long division. We're going to do synthetic division. So if we have a polynomial, if we have a polynomial divided by x minus c, two terms, two letters, an x and a constant, then we can use synthetic division. And the easiest way for me to explain how this works is with an example. So we're going to take the original polynomial. So here, f of x, the dividend, is 2x cubed minus 10x squared. Oh, there's no x term. I have to write plus 0x minus 5. And I'm going to write down just the coefficients, just the numbers in front. 2, negative 10, 0, negative 5. And then on the left, I'm going to have a vertical bar, and I'm going to put in the x's that I'm going to check. If we're dividing by x minus 4, I'm going to put down positive 4. So if we're dividing by x minus c, we're going to write down c. And here are the steps. We bring down the first number. We multiply and add. So let's see, 4 times 2.
Eight,
Minus 10,
2,
positive or negative?
negative.
Okay, good. 4 times -2
-8.
plus 0.
-8.
-8. Good. 4 times -8.
-32.
Yeah, so -32 plus -5, so -5. That's -37. And here's how we read this answer. The last value is the remainder. The other values are the quotient. Starting at the right of the quotient, we have x to the 0, then x to the first, x squared, and we continue. So I can write this quotient as 2x squared minus 2x plus -8, so -8. The remainder is -37. The divisor is x minus 4. And the dividend is 2x cubed minus 10x squared minus 5. So this method of dividing is lots less tedious and also neater and easier. So let's do another example, and then let's start trying to figure out what is going on. So now we're going to divide 2x cubed minus 10x squared plus 26x minus 130 by x minus 5. And we want to find the quotient and the remainder. So I'm going to put a horizontal bar, and we want to write down the coefficients of the dividend. So f of x is always going to be the dividend for right now. Dividend. What are the coefficients of the dividend?
2, -10, 26, and -130.
Good. If there's any x power missing, we have to put a 0 in, but this time we have 3, 2, 1, 0. Nothing missing. If we're dividing by x minus 5, I'm going to write +5. Then here are the steps. We bring down the first number. We multiply and add. So multiply, add, multiply, add. So let's see, 5 times 10, 5 times 2,
10,
minus 10.
0.
I'm going to write it down here so it's easier to see. 5 times 0,
0,
plus 26.
26.
5 times 26, let's see. 26 times 5, that's 30, 10, 130. So we get 130 minus 130,
0.
0. So what is our remainder?
0.
Good. The quotient is going to be the 3 terms that are left. Starting at the right of the quotient, we have the constant, so 26. Then we have the x term, 0x, and then we have the x squared term. So x squared, x to the first, x to the 0. We don't have to write the 0x, so the quotient is 2x squared plus 26. In the next example, I'm going to write down what y'all say, but I'm not going to write anything down if y'all don't say anything. So how do I start?
Make a horizontal line
All right.
and then make a vertical line. So it would be 3, 25, negative 48, and 20,
Good,
and then 1.
good. All right,
So we drop down to 3. So 1 times 3 is 3. Oh,
3 plus 28, 35, yeah,
28.
good. All right,
And then you subtract the 48 from the 28 and get negative 20. And
don't
then the
forget to
20.
multiply.
Oh, yes. And then the last two numbers, negative
So it's
20.
plus 20, yeah,
0.
good.
Yes.
So what is the remainder?
0.
0.
Good. Q of x, the quotient is the other terms at the bottom. We have x to the 0, x to the first, x squared. So we're going to have 3x squared plus 28x. When I have x to the 0, do I have to put x to the 0 down?
No.
That's right. It's just 1. So minus 20.
Mhm.
Excellent. Which part of this whole thing is the divisor? What is doing the dividing?
Is it 1?
It's x minus 1. Yes. So this 1 represents the whole x minus 1 factor. And which part of this is the dividend?
Is the numbers on top?
Yes, that's right. It's the original polynomial. Okay, let's do another one. How do I divide 2x to the 4th minus 3x squared plus 1 by x minus 1?
We write down the little lines
Yes.
first.
Okay,
So
Um,
you have to be
-3.
careful with this one. Yeah, 2. Where is x cubed?
Nowhere. So we write a 0.
That's right. Good.
-3.
mm,
And then 1.
And what about the x term?
Oh, another 0.
Good. So this first x is x cubed. We have 0x cubed. The second 0 is we have 0x. All right. And what do I put in the x column?
1.
mhm.
All right.
And then for the next one, it is 2.
And then we multiply and add.
Yes. And again, 2.
2 times 1
2 times 1
minus 3.
minus 3, negative 1. And then 0 to negative 1 is negative 1.
Good.
And then the negative 1 and the positive 1 go out, cancel out to 0.
Good. So what is the remainder?
It's 0.
And what is the quotient?
The
What
quotient,
x? Yeah, what
Mhm.
x's do we put in here?
2x to the third,
Good.
plus 2x squared minus x, and then minus 1.
Excellent, excellent, excellent. Does this kind of make sense?
Yes, ma'am.
Awesome. We're going to use this synthetic division for the rest of the semester.
Mhm.
There are some theorems that will help us out. The first one is if we're dividing a function by x minus c, that's the same thing as plugging c into f. So f of x divided by x minus c is equal to plugging c into f. That's what the remainder theorem says. That means that the remainder when you divide is equal to the remainder when you just plug in. The factor theorem says if f of c is a factor, if x minus c is a factor, then I plug in c, I get 0. And you can do it the other way around. If x minus c is a factor, then when I plug in c, I get 0. And then the last one is the most useful one, the rational zeros. So the only possible rational numbers, fractions or integers that can divide a polynomial are the quotients of the constant term divided by the leading coefficient. So all the factors of the constant term divided by all the possible factors of the constant. First, we're just going to play with the remainder theorem. So if we want to find f of 2, that's the same thing as doing synthetic division, plugging 2 in. Well, tell me how to do that, how to find f of 2 using synthetic division.
So at the very top, you would put 1,
Mhm.
6, negative 12, 30, sorry, negative 30, and a 35.
All right.
And for the column with 2, it would be with 1 to begin with. And then 6, 2. Oh, it would be 8 because it adds.
Okay, yes. 2
Yes.
times 1 is 2
2
plus
times
6 is 8. Very
Yes.
good.
And then you subtract the 12 from the 8, and that leaves you with
Well,
4.
First, we
You
multiply.
would multiply
Oh,
to
got
the 8 and then subtract the negative 12, which would be 4.
Yeah, so 16 minus 12 is 4. Good.
Okay.
And then multiply.
The next one would be negative 22. Multiply and then
Good.
subtract that. We'll add the negative 30.
So negative 44 plus 35, what is that? Negative 9?
Yes.
So what is the remainder if I divided f of x by x minus 2? What remainder would I get?
-9.
Good. And what is, if I plug 2 into this whole thing, what would I get?
That same number.
The same number. So that's what the remainder theorem says. I can find this answer using synthetic division. If I want to find f of negative 7, help me do it.
Plug in 1 again.
-8 subtracted by, oh wait, 8, positive 8 subtracted by -7. Wait, but you multiply the 7 and 1 first.
Yeah, so negative 7 plus 6.
Oh.
We're still
okay.
using this top. Yeah.
It'd be
Oh.
negative 1.
Mhm,
Good.
negative.
All right. And then negative 7 times negative 1.
Times negative.
7.
+7.
Positive 7 minus 12.
-5.
Good. Negative 7 times negative 5.
35.
35 and then
Good. 35 minus 30.
be 5.
Mm-hmm.
Good. Negative 5 times 5. Negative 7 times 5.
-35.
Negative 35 and then plus the 35 would be 0.
Good. So the remainder theorem says f of negative 7 equals,
0.
and that f of x divided by x plus 7 has a remainder of,
0.
and the factor theorem says that x minus negative 7, so x plus 7 is a factor of our original polynomial. So x minus negative 7 or x plus 7 is a factor of f of x. What is the quotient we have the remainder. We have that it's a factor. What is the quotient?
Is it 1 to the third?
Yes, because we've got third, second, first, and the 0th. So 1x cubed.
-1 x squared. -5x. And then 5.
Excellent. Excellent. So I'm only going to do what you tell me to do on this next example. We want to factor f of x if we know that x plus 2 is a factor. So let's see. What is that the same as plugging in? What number?
Is it -2?
Yes. And what am I going to put the -2 into? What do I put across the top?
3, 16, -5, and -50.
Excellent. Help me do it.
That'd be -6.
Yes, -6 plus 16.
10,
Good. 10 times -2
-20.
minus 5.
25, sorry.
Good. -25 times -2.
50 minus 50, 0.
Good. What is the remainder?
0.
What is the quotient?
X, 3x squared, cubed.
We start at 0, 1, 2. So it starts at the second power this time.
10x. And then -25.
Excellent. Okay. Well, let's just do more. Here's a longer polynomial. We want to find f of 5 and f of -3. That's kind of wonky. When the numbers are plugged in, you use that exact same number. When the number looks like a factor, you change the sign. So if I'm dividing by x minus 2, I would plug in +2. What numbers am I going to write across the top?
Wait, but wasn't that a -3?
Thank you. I need new glasses. No, I'm kidding. Okay, good. Thank you. Guillermo gets extra points today.
Do we include the zeros or the ones?
Oh yeah, we include all the numbers.
1, another one, -6, -5, and -15.
Excellent. What do I do first?
Drop down the 1, 5, 6.
Good. Yes, 5 plus 1 is 6.
30,
5 to- So 30 minus 6.
24.
$120 minus 5.
115.
Let's see, 115 times 5 is 565 minus 15.
550.
So what is f of 5?
550.
Good. And that means if we divided f of x by x minus 5, we would also have a remainder of 550. Let's divide f of x by x plus 3. In other words, let's find f of -3. Help me out.
It'd be -3 plus 6, 3.
But we're going all the way to the top.
Oh.
We still have to use the top row.
My bad.
That's cool.
Oh,
-3
the first-
plus 1.
-2.
Good. -3
The next
times
one.
-2.
The next one would be 0.
Good. Yes. 6 minus 6 is 0. -3 times 0.
0 plus -5 would be -5.
Good. -3 times -5.
15 plus -15 would be 0.
Yay. So what is f of -3?
0.
Good. Is x plus 3 a factor of f of x? X plus 3 is related to -3. If we have a remainder of 0,
Yes.
that's right, yes. And that's because the factor theorem says, if I get a remainder of 0, then x minus c, which is x minus -3 or x plus 3, is a factor. Okay, well, let's do another one. What number am I going to plug in if I'm dividing by x minus 2?
+2.
Good. And what numbers shall we put across the top?
Two, 4, -11, -17.
Excellent. Tell me all the steps, please. What do we do first?
Multiply the 2 times 2.
Good. And add,
4. So it
good.
would be 8. 2 times 8 is 16. Add -11 would be 5. 2 times 5 is 10. Add -17 would be -7.
Excellent. Is x minus 2 a factor of f of x?
No, because it's not a 0 at the end.
That's right. They're very good.
No remainder of 0, I should say.
That's right. Not 0. So if the remainder is not 0, then x minus this number is not a factor. This one I call the guided practice because it's big. So here we have 5x to the 7th, 0x to the 6th, -3x to the 5th, 0x to the 4th, 0x cubed, 2x squared, 0x, and -1. And we're dividing that by x plus 1, or we're plugging in -1. And it's the same thing. I bring down the 5. Tell me the steps, por favor.
Multiply -1 times 5 and add 0 to it. So it'd be -5.
All right.
-1 times -5 would be 5. Subtracted 3 would be 2.
Good.
That would be -2 plus 0, which would be -2. That would be +2 plus 0 would be 2. Would be -2 plus 2 would be 0. -1 times 0 is 0 plus 0 is 0. And then the last one would be -1.
Excellent. So is x plus 1 a factor of this f of x.
No,
That's right. Why not?
because it wasn't 0.
That's right. Excellent. This next one is just good for you. It's not, it's like medicine, you know. We want to see if x equals negative, x equals the square root of 5 will give us a 0. So I've got f of x is 1x cubed, negative 4x squared, negative 5x plus 20. And I want to plug in the square root of 5. So let's bring down the 1. What is 1 times the square root of 5? What is 1 times anything?
So it'd just be the square root of 5 minus 4.
Yes, good. Okay, so let's go to the side here to see what we get if we multiply the square root of 5 times the square root of 5 minus 4. Well, we have to distribute. What is the square root of 5 times the square root of 5?
Just 5.
Good. And then the other term is going to be 4 times the square root of 5. Okay. And let's see, that's what we get when we multiply, and then we subtract 5 from this. What is this whole thing minus 5? Are we just left with the 4 square root of 5? If we have 5 minus the square root of minus 4 square root of 5 minus 5, the 5s go away. We're just left with negative 4 square root of 5. Now let's multiply. Okay, good. We've got the square root of 5 times negative 4 times the square root of 5. So that's the same as negative 4 times the square root of 5 times the square root of 5. Well, what is square root of 5 times square root of 5?
5,
Good. And 5 times negative 4.
negative 20.
Okay, so when I multiply these two, I get negative 20. And what do I get if I add 20 to that?
0.
Yay. Oh my gosh. So is x minus the square root of 5 a factor of f of x?
C.
Yeah. Okay, good. These next are just sort of winding up what we've done before. So if I have a degree 3 polynomial, that means that n equals 3. And and f of x has a 0 of 2 with a multiplicity of 2 and negative 5 with a multiplicity of 1. I want to write a formula for f of x in factored form. So what the factor that gives us a 0 of 2, what is that factor going to look like? What can we solve to get x equals 2? So we had to start with x plus something equals 0. I think it's going to be x minus 2 equals 0 leads to x equals positive 2. Does that make sense? So a 0 of 2 comes from a factor of x minus 2. What about a 0 of -5? What factor does that come from?
Would that be an x plus 5?
Good. And it says the multiplicity of 2 is 2. How do I put that in?
Wouldn't that be square?
Good. And the multiplicity of -5 is 1.
So just no exponent, or I mean, you could put the 1 if you want to, but
That's right. Very good. Okay, let's answer these questions. Is there only one f of x that will work? And the next part might help you answer this question. What if the leading coefficient was 4? Would that polynomial work? If I stuck a 4 in here out front, would this form of f of x still have a 0 at 2 with the multiplicity of 2 and a 0 at -5 with the multiplicity of 1? Yeah, we can stick any number we want and we'll still have the same behavior for the zeros. So f of x can have any a sub n multiplied in front as long as the factors are x minus 2 squared and x plus 5 to the first power. So there are infinitely many polynomials that will work with the first conditions, but if the leading coefficient has to be 4, then there's just 1. And I noticed that the second question is exactly the same as the first. So let's look at example 20. We want a polynomial of degree 4 that has zeros at square root of 5, negative square root of 5, and 3. How do I write a 0 of 5? What factor does that come from? Do I put x plus the square root of 5 or x minus the square root of 5?
it would be negative square root of
Good.
5.
That's right. And the next one would be x.
Plus
Good.
square root of 5.
And then if we have a 0 of 3, we would put x plus 3 or x minus 3.
Minus 3.
Good. Now to see what the exponents are on these terms, it says that 5 and square root of 5 and negative square root of 5 are both multiplicity 1, and that 3 has multiplicity 2. What do I do with that?
You would put a square at the end of x minus 3.
Good. Could any number go in the front of this and still make all of that first line true? As long as it doesn't have an x in it, any number at all can go in the front. But if they tell us the leading coefficient has to be 1, if they say a sub n has to be 1, then there's only one possible f of x. Does that make sense? Awesome. There was a procedure that I forgot to do. It was right under, it was on page 9, right under the directions for synthetic division. There's really easy ways to tell if x minus 1 is a factor or if x plus 1 is a factor. Add up all the coefficients of the terms. If you get 0, then x minus 1 is a factor. If you add all the coefficients of the even terms and all the coefficients of the odd terms, and you get the same number, then x plus 1 is a factor. We're going to use that a lot. We're going to use it in particular right here. So I have f of x equals x to the 4th minus 2x cubed minus 3x squared plus 8x minus 4. And let's add the coefficients. What's the coefficient of x to the 4th?
One.
Good. So I have 1 minus 2 minus 3 plus 8 minus 4. Let's see what that is. 1 minus 2.
-1.
Good. -1 minus 3.
-4.
Good. -4 plus 8.
4.
Good. And 4 minus 4.
0.
That means that x minus 1 is a factor of f of x. So we're going to use it to start whittling down our f of x. So I'm going to plug in 1 first because x minus 1 is a factor. I know I'll get a 0 remainder. What numbers do we put in the top here?
-1, -2, -3, 8, and -4.
Great. And we bring down the 1. Okay, now what?
Multiply 1 times 1 and add the -2.
Good.
Multiply 1 times -1, which is -1 minus 3 would be -4. And then 1 times -4 is -4. Plus 8 would be 4. And then 1 times 4 is 4.
Excellent. Let's see if x minus 1 is a factor again. Anytime we get a 0 for a remainder, we can use the quotient to divide into. So let's see, what is 1 minus 1 minus 4 plus 4?
It would just be 4.
Did we get 4 or 0? 1 minus 1 minus 4 plus 4.
Oh, 0, sorry.
That's okay. So that means that x minus 1 will work again. And since we got a 0 remainder, I can plug into these new numbers. So I'm going to bring down this one. We get 1 minus 1.
It'd be -1.
1 minus 1.
Oh, 0.
Good. And then 0 minus 4.
-4.
Good. And then -4 times 1.
-4 as well, and add the 4, which would be 0.
Yay. At this stage, we have how many terms in the quotient? How many terms? One, two, three. So we have a quadratic, has three terms. So it's anytime we get down to a quadratic, it's easier just to look at that as a quadratic. So Q of X is 1x squared plus 0x minus 4. Do we know how to factor x squared minus 4?
Yeah, wouldn't it be x plus
Oh,
2?
Lucina, yes. So we get x plus 2, you said?
Yeah, and x minus 2.
Good. Because it's the difference of two squares. So that means that the factors of f of x are x minus 1 times x minus 1 times x plus 2 times x minus 2. And what does that mean that the zeros are?
So wouldn't
You too,
we just
Messina. Go ahead.
wouldn't we just add it, to give us our zero? So that would be 1, and then that would also be 1, -2 for that one, and then +2 for the other one.
Excellent. What is the exponent on the x plus 2 factor?
Wouldn't it just be just odd? Yeah, odd.
Yeah.
One.
What is the exponent on the x plus on x minus 2 factor?
Add odd as well. So 1,
But how many x minus 1s do we have?
2. So that would be even.
That's right. So we can actually sketch this. The degree of f of x is 4. What is n and what is a sub n?
N is 4, and a sub n is 1.
And what do we care with n?
Even or odd, so that one would
Good.
be even.
And with a sub n?
Positive or negative, that would be positive.
So that goes up to the left and up to the right. The zeros are at 1, -2, and 2. And what does it do at -2 and 2?
It goes through it,
Good. And at -1?
it touches it. And then same for negative, for +2. Oh no, yeah, it's odd.
This is supposed to be touching, but yes, very good. All right, let's do more. We're going to do these for the rest of class. Oops. Okay, again, they want us to find all the factors. What numbers do I write across the top?
1, 3, -4, and -12.
Good. And let's see if 1 or x minus 1 is a factor. We've got 1 plus 3 minus 4 minus 12. Do we get 0? Looks like 1 plus 3 is 4, minus 4, that's 0, minus 12 is -12. So x minus 1 is not a factor. Let's see if x plus 1 is. Let's add all the odd numbers. So all the odd terms, 1 plus -4, that's -3. All the even ones, 3 minus 12, that's -11. They're not the same number. So x plus 1 also doesn't work. And let's go ahead and look back at the rational zeros theorem, because we're going to start using it. Momento, por favor. Here it is. The rational zeros theorem tells us what possible numbers we can plug in. We take the constant term and divide it by the leading term, leading coefficient, and we look at all of the factors of those numbers. So here, a naught is -12, a sub n is 1. So the possible rational zeros are, well, let's see. What is a factor of 12? What is one factor of 12? Does 1 go into 12? Yeah. So positive or -1, positive or -2, because 2 times 6 is also 12. Positive -3, 3 times 4 is 12, so that works. Positive -4 also works. 6 also goes into it, and 12 goes into 12. What are the possible factors of 1? It's just positive or -1. That's good. That means that the possible rational zeros are positive or -1, positive or -2, positive or -3, positive or -4, positive or -6, positive or -12. Is 5 a possible rational zero?
No.
That's right. Very good. And we've already done a quick check to see that positive and -1 don't work. So in this long list, what do you want to try next?
So it'd be the positive -2.
Okay, which one?
Let's go with positive.
All right. 2 times 1,
2 times 1 is 2, plus 3 is 5.
10 minus 4.
6.
6 minus 12 minus 12. Yay.
0.
Excellent. Let's pretend that this isn't a quadratic. Which zeros over here, which possible zeros can we X out now? Because our A naught was negative 12, now it's 6. What numbers over here are not factors of 6?
$12 plus
Good.
or minus negative or positive 12. So yeah.
And there's one other that we can get rid of. One other number in this list doesn't go
4,
evenly in.
sorry.
Good. Okay. So what do you want to try? You want to try negative 2? So bring down the 1. What is 1 times negative 2?
-2. And add the 5, that would be +3.
Good. Negative 2 times 3?
That would be -6 plus 6 would be 0.
Yay. Let's pretend that we can't tell what the last answer is. If we plug in a negative 3, bring down a 1, negative 3 times 1?
-3 plus 3 would be 0.
Good. Let's write f of x in factored form. What were the 3 factors?
So would it be x minus 2 and then x plus 2 and x plus 3?
Good. Yes, you always change the sign. We have time to do one more. So first, we're going to write down all the possible rational zeros. What is a naught for the polynomial f of x equals 2x cubed plus 5x squared plus x minus 2? What is the constant term? -2. And what's the leading coefficient?
+2.
Good. That means that the possible rational zeros are the factors of a naught divided by the factors of a sub n. Well, what are the factors of 2? What numbers go evenly into 2?
1 and 2.
Good. And what about the denominator? What numbers go evenly into that too? So yes, it's going to be the same. So now let's see what kind of numbers we can get. We've got, if I divide by 1, positive or negative 1 divided by 1, that's just positive or negative 1. Positive or negative 2 divided by 1, that stays positive or negative 2. What is 1 divided by 2? Is that a new number for us? Yeah, sure. We've got positive or negative 1/2. And then 2 divided by 2, is that a new number? What is 2 divided by 2?
It'd be positive -1, so that wouldn't be a new number.
That's right. Now, we can always take care of the positive or negative ones by looking. Let's add up the coefficients and see if we get 0. What is 2 plus 5?
7 plus 1 would be 8, minus 2 would be 6.
Right. So does positive 1 work?
Yeah.
do we get 0?
No.
And let's see if -1 works. Let's add up the odd coefficients. 2 plus 1,
3
5 minus 2.
would be 3.
So that means that -1 will work. And that helps us. So we have 2, 5, 1, -2. And we're going to start out with -1 because we added the odd coefficients and the even coefficients, and we got the same number. 2 times -1 plus 5.
3.
Good. 3 times -1
-3 plus the 1 would be 2.
2 times -1.
Uh,
Oh, wait, it should be negative. This is negative, yes. 2 times
sorry.
-1 times -2.
That'd be +2 minus 2 would be 0.
Good. And the remaining quadratic, let's see if it can be factored. That would be 2x squared plus 3x minus 2. A long time ago, like a couple of weeks ago, we said if the discriminant is a perfect square, we can factor. Well, let's see. We've got B is 3, A is 2, C is -2. That's 9. 4 times 2? And then we still have to multiply by another -2. What is 8 times -2?
It'd be a +16.
Excellent.
Sorry, did you
And
say -8?
yeah, -8 times -2 is +16. And then +16 plus 9.
25.
Yay. So we can factor this, and this is a good one to factor. So since A is not 1, we want to find A times C for the product and B for the sum. Let's see, B is 3. What is A times C? Two times -2, -4. What are any two numbers whose product is -4? How about 4 and -1? Because 4 plus -1 is 3, and that's what we want. So we're going to rewrite our quadratic. We're going to replace 3x with +4x minus x, but I want to put the -1 first. So I've got 2x squared minus 1x from this, plus 4x minus 2, and we're going to factor by grouping. The first two factors have an x in common. The last two have a 2 in common. The remaining factors match, so pull it out, 2x minus 1. We're left with x plus 2. That means if we had tried -2, it would have worked. And if we had tried +1/2, it would have worked. So that our final function, f of x, is equal to x plus 1 times x plus 2 times 2x minus 1. So that's f of x in factored form, and we factored completely using synthetic division. That's our time up. I'm going to go ahead and stop the recording.